We are continuing our lesson on exponent practice, and we have a little application question here. It says a square-based pyramid has a base length of 3 to the power of 100 millimeters and a height of 3 to the power of 58 millimeters. Determine the volume as a simplified power, and then it gave me the formula V equals B squared H divided by 3. So if I want to calculate the volume of that square-based pyramid, I'm going to try using this formula. So I'm going to write the formula down first. So volume equals B squared H divided by 3. Now B stands for the base, which is 3 to the power of 10 millimeters. So in place of B, I'm going to put 3 to the power of, I think I said 10 earlier, but it really is 100. So 3 to the power of 100. And I put it in a bracket because there is a square on B, so I need to put a square to show that that is squared. And then we are multiplying by the height, which is 3 to the 58. So I'm going to use a bracket to show that we're multiplying, and then 3 to the 58. And then that is divided by 3 from the formula. Okay, so the first thing I notice when I look at this is that they all seem to have a base of 3, which is good because my exponent laws only work on things that have the same base. And when I'm trying to work this out, I am always trying to use order of operations or BEDMAS. So I am going to start by looking to see if I have any brackets and then exponents and then multiplication and division. So I do notice that I have brackets, but the reason I put those brackets in, the first bracket was to show the separation between the two powers, and the second bracket was to show multiplication. So there isn't anything to do inside those brackets. I do, however, have an exponent or a power on a power, and that is that power of 2 on my 3 to the power of 100. So we learned that when you have one base with two exponents, you leave the base the same, and you multiply the exponents. So 100 times 2 is 200. So I have 3 to the power of 200, and that is still times 3 to the power of 58. So I am going to use a bracket just to show that we are still multiplying. And then that is divided by 3. 3 to the power of 200 times 3 to the power of 58. When you multiply two things with the same base, you leave the base the same, so it stays at 3. And then we don't multiply when we multiply, we add our exponents. So 200 plus 58 is 258. So I have 3 to the power of 258 divided by 3 in the denominator. So now all I have left to do is that division. And I do notice that they have the same base. Now that number on the bottom, that 3, has a secret exponent of 1. It's shy. It doesn't like to stand out, so we don't usually write it down, but we do need to kind of, make it show itself so that we can do our next step. So our volume is going to be 3 to the 258 divided by 3 to the 1. When we divide, we leave the base the same and subtract our exponents. So 258 minus 1 is 257. So our volume is 3 to the power of 257. I don't want to work that out on my calculator because that number is way too big for my calculator to handle. So I'm going to say, therefore, the volume is 3 to the power of 257. That is millimeters. And when we're doing volume, because we were multiplying the base times the height, we were multiplying millimeters times millimeters times millimeters, which means my unit is millimeters cubed. And that's what you need to know about exponent practice today.